Alright, it is already time for you to get started with your first activities for this class. There are no labs this week. However, it's important for you to get access to the lab and making sure your UID card is letting you enter the lab. You also have to form teams and make sure that you buy the different hardware elements such as your discovery kits. Make sure also to get a Kate account if you don't already have one. Most importantly, we're starting with our homework activity. And this homework does consist, as I said, in making the analog interface for your DC motor control system. There are a couple of very important things that you will have to do. Of course, guidelines will be posted on Canvas, but let me emphasize two things. You will have to, first of all, read the technical documentation of the components we're recommending. Second, you have to prepare questions and come prepare on Thursday where you will have a help session and an introduction to the Eagle PCB software. Be ready to ask for any questions you might have. Do not put that late. It's a difficult homework, and doing that at the very last minute always creates problem every single year. Here's what we do, in fact, in this homework. As you can see on our system, on the left, we have our microcontroller board, and this microcontroller simply deals with digital logic. You basically simply have I/O pins working between 3.3 volt in a very digital fashion. On the other end, you have a DC motor system, a DC motor that you want to control. How can you control a DC motor that requires milliwatts, if not watts of power with a simple GPIO pin of a very tiny microcontroller? You can't. You need to implement an analog interface, and this is the purpose of your analog board. This board will contain an H bridge, the H bridge being here to create this power interface between your microcontroller and your DC motor, allowing the motor to turn in both directions thanks to a simple control pin, and the speed being adjusted, or the torque being adjusted thanks to the PWM signal. We are also taking care of the data from the sensor, the encoder sensor, that will go back to our digital board. Thanks to this board, we have a torque sensor, that is a current sensor that goes through the motor, as well as a temperature sensor. This homework will guide you through the process of making a physical board that implements this kind of specs. So homework 1 is the introduction, so the homework is the introduction to PCB design. Check out on Canvas for detail and submission. This homework will have 4 parts. The first part will consist of making a schematic using Eagle. The second part will be building your layout, and then the third part is about sending your board for manufacturing through Park, and finally you will have the board assembly. You have to pay for manufacturing and parts, but as I told you already, cost is fairly moderate. We are going to use the tool Eagle that is available either as a freeware or with EDU license. More details are also given on Canvas about that.